Hello friends, I welcome you on my channel Engineering Mathematics DJ Ganit. In this lecture we are going to discuss two more examples on limit of a function of two variables. So let's start with this example or question number 1. Find limit of xy over square root of x square plus y square as xy approaches 0, 0 if exists, or show that the limit does not exist. So as usual we can check by putting different paths in given function. Given function is xy over square root of x square plus y square. So first we check along the lines passing through origin. So if we put y equal to mx, we will have x times mx over x square plus m square x square. So here x square will be common, and if we take square root of x square it will be x, and that will cancel out with this x. So this will be reduced in m into x over square root of 1 plus m square, and as xy tends to 0, 0, x is tending to 0. So if we take limit as x tends to 0, limit will be 0 along all possible lines passing through origin. So now we check along all the parabolas. We are just roughly checking to get the idea whether there are chances that limit exists or not. So now we try for limits along parabolas. Y equal to mx square, x is non-zero. So if we put y equal to mx square, we have x into mx square over square root of x square plus y square, that is m square x raised to 4. So here also we can take x square outside. That x square will cancel out with this x, and we will be left with mx square over 1 plus m square x square, and if we take x tending to 0, this is going to be 0. Similarly, if we try for different paths like x equal to my square or y equal to mx cube, you can try along these different paths, and you will see that we are getting limit as 0 along all these possible paths. So from this we have the idea that limit may exist and the value of the limit may be 0. So we try to prove by definition whether the limit is actually 0 or not. So we have discussed how to prove the limit using definition in the last lecture. Here also we will do the same thing. We try to prove that limit is 0 by definition. So we want to prove that limit of xy over square root of x square plus y square as xy approaches 0, 0 is 0. So we start by taking epsilon positive. Let epsilon greater than 0 be given, and we have to find out corresponding delta. So as we have discussed, we will try to find out the relationship of this form. We will try to establish this type of inequality. Distance between fxy and L is less than or equal to distance between xy and 0, 0. This is negative sign. So we will be in search of this alpha, which is non-zero real number. So if we are able to prove this, then we can show that given limit is 0. So we start from this fxy minus L. Here limit is 0. We want to prove that limit is 0. So we start by fxy, which is function is xy over square root of x square plus y square minus 0. So we try to establish that type of relationship. Now this is nothing but absolute value of xy over square root of x square plus y square. This we can rewrite as absolute value of x into absolute value of y, and square root of x square plus y square is non-negative, so we keep it outside modulus. Now we know that y square is always less than or equal to x square plus y square for all values of x and y. So this gives us that if we take square root on both sides, square root of y square is less than or equal to square root of x square plus y square for all possible values of x and y. Now square root of y square can be written as absolute value of y, which is less than or equal to square root of x square plus y square for all possible values of x and y. So from this we obtain absolute value of y over square root of x square plus y square is less than or equal to 1 for all possible x and y. So we can use that fact here. If we use that fact here, you can see we have absolute value of y over square root of x square plus y square, which is less than or equal to 1. So if we multiply both sides with modulus of x, then we obtain this inequality. This is less than or equal to modulus of x for all x, y. Of course x and y are non-zero because we are having limit as xy tending to 0, 0. So x and y will go near to 0, but they will never be 0. So there is no problem when dividing with this square root of x square plus y square. So we can use this in this inequality. We can give this number 1. So we obtain that mod x into mod y over square root of x square plus y square is less than or equal to mod x. So using this, in 1 we have xy over square root of x square plus y square minus 0 is less than or equal to mod x mod y over square root of x square plus y square, which is less than or equal to mod x. So here we write absolute value of x. Now absolute value of x is square root of x square, and as we know x square is always less than or equal to x square plus y square. So square root of x square plus y square is always less than or equal to square root of x square plus y square. So x square is less than or equal to x square plus y square. Therefore square root of x square is less than or equal to square root of x square plus y square. So what we obtain, distance between xy over square root of x square plus y square, distance between xy over square root of x square plus y square and 0 is less than or equal to square root of x square plus y square, which is nothing but distance between order pair xy and origin, that is 0, 0. So we can give this number 1. So from 2 we can see that if this distance is less than epsilon, then this is also less than epsilon. So by 2 we can write xy over square root of x square plus y square minus 0 is less than epsilon if distance between xy and 0 0 is less than epsilon. So this suggests that we have to take delta equal to epsilon. So let delta equal to epsilon, then we can rewrite this as then distance between xy over square root of x square plus y square minus 0 is less than epsilon if distance between xy and 0 0 is less than delta. So for every epsilon positive there exists delta which is equal to epsilon, such that distance between these two is less than epsilon whenever distance between xy and origin is less than delta. So therefore by definition we can say that limit exists and value of limit is 0. xy approaches 0 0 is 0. So now it is not hard to show that limit exists. We only have to take care that we should find corresponding delta for given epsilon positive. So for that we always try to establish this type of relationship between these distances. Distance between xy and AB is, so if we are able to establish this type of relationship, then we can prove that limit of fxy as xy tends to AB is L if it is possible to establish this type of relationship for some non-zero number alpha. So here order pair AB is 0 0 and capital L is 0. So we started from this distance and we showed that this distance is nothing but less than or equal to distance between xy and 0. So we are able to establish that relationship between these two distances. So this suggests that we should take delta equal to epsilon. We consider one more example of limit. Check whether limit x cube y over x raised to 6 plus y square exists or not. So here also we first try to check along different paths. So if I put y equal to mx, then I check what is our function first. First we check what is our function along this path. So x cube times m into x over x raised to 6 plus m square x square. So x square will cancel out and we will have 1x here, there is 1x here. M into x square will cancel out, so here we have x raised to 4 plus m square, and because x is non-zero we can cancel out. So if we take limit xy tends to 0 0 along this path, line passing through origin, then we are converting y in terms of x. So here this is equivalent to writing limit x tending to 0, and our function is mx square over x raised to 4 plus m square along this path. So if we put x equal to 0, we are left with 0 over m square, which is 0. This shows that limit is 0. Here of course we should mention that m is non-zero. So limit is 0 along all possible lines passing through origin. So we try along parabolas. Along y equal to mx square, m is not equal to 0, x is not equal to 0. So first we examine what is our function along this path. Function is x cube y over x raised to 6 plus y square. So we put y equal to mx square. X raised to 6 plus y square means m square into x raised to 4. Now we can take x raised to 4 common, that will cancel out with x raised to 4 and we are left with m into x. X raised to 4 will cancel out, so here we have x square plus m square. So here also if we take limit as xy tends to 0, 0, x cube y over x raised to 6 plus y square, this is now limit x tends to 0, m into x over x square plus m square, and if we put x equal to 0, we have 0 over m square, and because m is non-zero, limit is 0. So along all the parabolas passing through origin, limit is 0. So let us try along cubic curve. So now we check along y equal to m into x cube. So let us try along y equal to m into x cube. M is non-zero, x is non-zero. So the function is x cube y over x raised to 6 plus y square, and we put y equal to mx cube. So y equal to mx cube will be m into x raised to 6 over x raised to 6 plus m square, that is m square x cube square, that is x raised to 6. So here we can see we can cancel out x raised to 6 and we are left with m over 1 plus m square, and we cancel out x raised to 6 because x is non-zero. So now we check limit along this path. X cube y over x raised to 6 plus y square, xy approach is 0, 0. This is equal to limit x tends to 0, m over 1 plus m square, and this is independent of x, so limit is m over 1 plus m square. So we have the limit which depends on m. That means the limit is different for different values of m. That means the limit is different along different curves, different cubic curves, y equal to mx cube. So for different values of m we have different cubic curves passing through origin. So limit depends on m, that means limit is different along different cubic curves passing through origin. That means the limit is not same along all possible paths passing through origin. Therefore, given limit does not exist. X cube y over x raised to 6 plus y square does not exist. So we obtain same limit along y equal to mx, that is along all the lines passing through origin. Limit is same 0. Similarly, limit is same 0 along all the parabolas passing through origin, but we obtain that limit is different along different cubic curves passing through origin. So that shows that limit does not exist. So in examination you just have to write this part along y equal to mx cube. You need not write the previous part, but you can go up to this path by taking different paths. So if you are able to identify that along this path you will have different limits depending on different values of m, then you can directly try y equal to mx cube. And if you are not sure, then you can try in sequence. First we put y equal to mx, then y equal to mx square, or we can try for x equal to my square. Similarly, y equal to mx cube, then x equal to my square, and so on. But if we are getting same limit along these 3 or 4 different families of curves, then from that we cannot say that limit exists. We have to prove the existence of limit by definition only. But for non-existence, we can try to find out the different paths like this, so that we obtain different limits along different paths. So here we are successful along this path, along y equal to mx cube. We are able to show that limit is dependent on m, therefore limit does not exist. So in this way we can try to show that limit exists by definition, or we can prove that limit does not exist by taking different paths as we discussed in this example. So I hope you like this lecture. In the upcoming lecture we are going to define continuity of a function of two variables. Thank you very much.